The dream of flying cars has captured human imagination for decades. From the Jetsons to Back to the Future, we've fantasized about a world where the skies are buzzing with sleek, hovering vehicles, lifting us above the traffic jams and into the future. But here's the twist. What once felt like distant science fiction is inching closer to reality, thanks to one game-changing innovation: artificial intelligence. Imagine skipping rush hour altogether. No horns, no gridlock. Just smooth, autonomous travel through the skies. This is the promise that companies and engineers are working toward. But as with any revolutionary technology, turning dreams into reality involves confronting some seriously complex challenges. Part 1. The current state of flying car technology. To start, let's break down where we are today. Flying cars, also known as eVTOLs, electric vertical takeoff and landing vehicles, are no longer conceptual sketches on a drawing board. They're being prototyped, tested, and in some cases, even flown. Companies like Joby Aviation, Lilium, Archer Aviation, and Vertical Aerospace have all developed test models that can lift off vertically like a drone and cruise like a small airplane. These machines are often fully electric, environmentally conscious, and designed for short urban flights. But here's the catch. Building a vehicle that flies is one thing. Making it safe, autonomous, efficient, and scalable for everyday use. That's where AI becomes absolutely critical. Part 2. Why AI is essential to flying cars. Artificial intelligence isn't just helpful for flying cars, it's fundamental. Here's why. 1. Autonomous navigation. Flying in the air is far more complex than driving on roads. There's no fixed path like a highway, and variables like wind, buildings, birds, and other flying vehicles add layers of complexity. AI-powered navigation systems allow flying cars to sense and avoid obstacles in real time, plan optimal flight paths, adapt to weather and wind conditions, coordinate with other aircraft to avoid mid-air collisions. 2. Real-time decision-making. Traditional aircraft rely heavily on pilots. But for flying cars to scale, especially in urban areas, we can't expect every user to be a licensed pilot. AI steps in as the virtual pilot, making split-second decisions using sensors, radar, lidar, and predictive models. 3. Energy efficiency. AI helps optimize battery usage by choosing efficient flight routes, adjusting propulsion in response to drag or turbulence, and predicting maintenance needs to prevent breakdowns. Part 3. The biggest challenges facing flying cars. Despite the hype, flying cars face some massive obstacles, both technical and social. 1. Regulatory hurdles. Who controls the sky? Right now, aviation is strictly regulated by organizations like the FAA, US, and EASA, Europe. Flying cars introduce a gray zone. Are they drones, helicopters, or something entirely new? Regulators need to define air traffic rules for low-altitude urban skies, certify safety standards for autonomous flight, ensure privacy and noise concerns are addressed. 2. Safety and public trust. People are hesitant to board flying machines without human pilots. One accident could set the industry back by years. That's why rigorous testing and transparent communication are essential. AI systems must prove they're more reliable than human pilots. 3. Infrastructure needs. We don't have sky highways yet. Urban planning will need to adapt, possibly by building vertiports, dedicated landing, takeoff pads, charging stations for eVTOLs, air traffic control systems for autonomous vehicles. 4. Noise pollution. Early prototypes were often as loud as helicopters. However, AI-controlled electric propulsion systems can help reduce noise by synchronizing multiple smaller rotors for a quieter lift. Part 4. Game-changing projects. LED by AI. Let's talk about some specific examples that show how AI is already making a massive impact on flying car development. Glowing Star Lilium Jet. This German-designed eVTOL is fully electric, powered by 36 small jet engines integrated into its wings. What sets it apart? AI controls the precise tilt and thrust of these engines. It manages dynamic transitions between vertical lift and horizontal flight. It can reach speeds of up to 300 km per hour, 186 miles per hour. The Lilium jet completed several successful test flights and aims to launch a commercial service within the next few years. The AI onboard is responsible for flight stability, route optimization, and real-time diagnostics. Glowing Star Joby Aviation Joby is another frontrunner. Their 5-seat eVTOL has completed over 1,000 test flights. What's revolutionary here is full autonomy assisted by AI integration with AI-driven air traffic management systems, real-time data processing to predict maintenance before issues occur. Joby is working with NASA and the U.S. Air Force to test its capabilities in real-world conditions. Glowing Star Whisk Aero, a Boeing-backed company that is developing an autonomous passenger-carrying air taxi. With no pilot, the entire system relies on AI. From takeoff to landing to respond to emergencies to manage passenger safety in mid-air. Part 5. How AI learns to fly. Let's break down how these AI systems are actually trained. AI models in flying cars typically go through simulation training, thousands of simulated flights with different weather, terrain, and obstacle scenarios. Sensor fusion AI integrates data from lidar, radar, sonar, infrared, and visual cameras to see the environment. Reinforcement learning. The AI is rewarded for efficient, safe behavior, similar to how you train a dog to do tricks. Digital twin. Some companies create virtual replicas of their flying vehicles to run predictive models. These digital twins help engineers test new features without physical risk. Part 6. Future applications of AI-powered flying cars. Flying cars won't just be cool gadgets for tech billionaires. AI could unlock a wide range of practical applications. 1. Air taxis. Think Uber in the sky. AI manages fleets, customer pickup, drop-off, and flight routes, all without human intervention. 2. Emergency medical transport. Flying ambulances could drastically reduce response times, especially in congested urban areas or remote regions. 3. Disaster relief. AI-controlled flying vehicles could deliver supplies, rescue victims, or survey disaster zones faster and safer than helicopters. 4. Freight and cargo. Before human transport becomes widespread, expect AI-powered drones and flying vehicles to deliver packages and goods. Amazon and UPS are already experimenting in this space. Part 7. Will flying cars be affordable? Right now, these vehicles are expensive, ranging from hundreds of thousands to millions of dollars. But AI can help reduce long-term costs by lowering operational expenses via autonomous piloting, predicting and preventing mechanical failures, reducing energy costs with smarter flight optimization. As mass production increases and economies of scale kick in, prices will drop. Think of it like the early days of electric cars. Tesla was premium at first, but today, there are EVs for every budget. Part 8. The road, or sky. Ahead. The road to mainstream adoption of flying cars is long, but not impossible. Here's what needs to happen. Continued AI development and transparency to ensure public trust, collaboration between tech companies, city planners, and regulators, infrastructure development, charging hubs, sky corridors, and air traffic networks, clear legislation for safety, certification, and liability. If these hurdles can be overcome, and with AI, they just might be, then flying cars could become part of everyday life within the next 2 decades. Conclusion. Are we ready for takeoff? So, can AI make flying cars a reality? Absolutely. In fact, AI may be the only reason flying cars can scale to real-world use. From managing complex navigation systems to ensuring safety, efficiency, and sustainability, AI transforms what was once science fiction into a real possibility. We're at the dawn of an airborne revolution, where traffic jams become obsolete, and your morning commute could involve cruising over city skylines. But this dream only works if AI continues to evolve, because without it, flying cars remain grounded. Call to action. What do you think? Would you ride in an AI-powered flying car? Do you trust a machine to take you 500 feet above the ground? Drop your thoughts in the comments. I'd love to hear your take on the future of air mobility. And if you're as fascinated by futuristic tech as I am, be sure to check out my other videos on next-gen robotics, smart cities, and space exploration. Don't forget to smash that like button, subscribe, and turn on notifications, because we drop tech gems every single week here on TechWave 65.